Well, good morning. Do you want to make an announcement?
Hey guys, real quick, just to let y'all know, AICHE has a meeting this Thursday. It's with BASF. It's going to be at 7:30 in room 105 in the building. Food provided, as always. April 1st through 3rd, they're having the AICHE regional conference. I'm not sure of the location or the price. If y'all want to sign up, y'all need to come to the meeting, and I think they're going to be doing a sign up there. It's a good opportunity for networking with both professionals in industry and academics. Also, they're still doing the sale for engineering paper. It's going to be 3 tablets for $10. I think it's only going to last about another week. And they should be putting a refrigerator in the AICHE building, the chemical and engineering building, pretty soon. So, that's it. Show of hands, how many people are going to come to the meeting on Thursday? Okay, thank you.
Okay, are there any questions for me? Comments? Yeah? Okay, the question is, can we move this Wednesday's help session on MATLAB because conflict with organic test? So, do you want to move it to Thursday evening at the same time? Thursday you have that, okay. Pardon me? Any other suggestions? Tonight, I'm game for tonight. I still haven't verified that room. The library, I got an email from the coordinator saying that she thinks that MATLAB MATLAB is not installed, so I have to go there and check. But maybe you can access it via VLab from that room. So after the class, I was going to go there and talk to the person. If not, if that doesn't work out, then maybe I have requested Rob to put an overhead projector in our computer lab. It's not the ideal, but we may have to stick with the current lab in chemical engineering. So I will post it on Moodle. Keep watching, but we need to agree on a time now so that we get the attention of most people. So if we have it tonight at 6 o'clock, would that work? Or you? Okay. Personally, I feel that unless you have a lab and a computer in front of you that you can work with as we are working through those problems, the benefit is not going to be as much. If I record some help and put it, how many of you would find that as a substitute, that you do it on your own? I will post the problem and I will take you through the solutions, but let me tell you my feelings so far based on the assignments and based on the interactions that I have had with many of you in my office. Majority are meeting up to my expectation in terms of picking up MATLAB, and I think you're putting in the effort. There are a few who are struggling, and that may need an individual one-on-one attention to know what the problem is and then kind of prescribe you a path forward to pick up MATLAB. Okay. I was going to talk about what are the things that you need to do in general to continue to learn MATLAB on your own. So there's an entire spectrum. I've seen people who've done extremely well in terms of picking up new things on their own, which is what I want everybody to be able to do. But I know computers are not everybody's cup of tea, so there are other extreme people who need help. But if you need help, you have to come and tell me. Don't wait till the last minute. Okay, then it's very difficult. The pressure only increases and on you, and so it's not helpful. So the earlier you diagnose your problem and come to me, I'm willing to spend the extra time to tide you over and get some handle on how to deal with computing environment in general. Later on in this course, we will introduce other software tools like HiSys and ComSol. You will find that they are a lot more easier, but still the problem of understanding what it is that you're solving and able to express that in that environment, computing environment, you need to work on that. Okay. So having said all this, I will maybe record some sessions until I find another room. So this week we won't have a help session for MATLAB, but you will have an online help session, meaning I will pick up some problems that emphasize the points that I want to emphasize and record a narrative on that as I run through it, and then you listen to it and you will benefit it if you work with MATLAB and try not only what I've asked you to do, but variations on that. Shall we try it this week that way? So there is no scheduled online help, but there will be a tutorial for this week that will be in Moodle that you can follow on your own. And if you have questions, you're always welcome to drop by. Yeah. I put all of these on YouTube as well. And there is a channel that I have created in YouTube. So if you subscribe to that YouTube channel, all these lectures should come out in an orderly fashion. Okay, lecture 1, lecture 2, lecture 3, etc. tutorial. I have to break them up into chunks of 12 minutes or so because YouTube has a time limit. So there is a direct link here on the web page that you will see. There are many ways to download it. Here is one way to download, which just gives you access to the folder. So you can just download it onto your device. If you have a portable device, a media player, iPad, whatever it is, you can download into that. Or you can go to Tiger Bytes and YouTube. Okay, so if you click on YouTube, it should take you to the channel. Okay, this is what they call channel, where you can organize material by lecture 1, lecture 2, lecture 3, etc. Okay, so you should be able to access from anywhere. Okay, and I think there is a way that you can subscribe. A few of you have figured that out as well, because I see a few subscriptions to this channel. 6 people so far. I really don't know what the subscription does. Maybe it sends you an email. I don't know. Okay. The other thing I wanted to point out is there is a link on MATLAB resources. So I'm populating this with many material. I'm not explicitly talking about them in the class in the hope that you will browse through this and figure out by yourself. There is always a date at the front, approximately on which day I post that. And if you click on the MATLAB resources, this is something that is very useful, put together by MathWorks, the people who make MATLAB. And Clay Moeller is a computing scientist who was one of the founders of MATLAB in the 70s or so. So he has a book which is freely available, downloadable, excellent book. And you can download, for example, today we're going to talk about iteration. So you can download that chapter. And I'm not taking the material from there, because my focus is on chemical engineering problems, mathematical modeling of chemical engineering problems, and how to use MATLAB to solve them. He will have problems from just mathematics, very interesting problems about exponential function. There is one on exponential function, okay, one on ordinary differential equation, one on Mandelbrot set, which is a very fascinating concept of fractal dimensions. And the current assignment that you are doing will touch on those aspects. For example, you will see something called a strange attractor as you're doing ODE integration of ordinary differential equations. And it occurs in many chemical processes. There are chemical reaction models that lead to so-called chaotic dynamics. And so kind of exposure to that concept through this assignment. Okay, so this is an excellent source. And you can download it. These are all just PDF files. Then open up a MATLAB. He has snippets of codes. Try to understand what these codes do. The way that I learned MATLAB, when I was studying, MATLAB didn't exist. It was created afterwards. So I learned MATLAB basically on my own. How? Simply going through these resources, online resources, looking at the codes. But I was programming in other languages like Fortran, for example. So if you have other experiences, it makes it a bit easy, but still MATLAB is the best environment to start learning programming because it's interactive. Okay, so you can take a piece of code and just copy it and paste it and see how it responds, and you can understand that. So if there is a complicated piece of code, just break it up line by line. Even within the line, within a parenthesis. Just take that code and type it in and see what it does. So you can learn that way. And I think that's the best way to learn. So this is what I'm trying to do in the tutorial sessions as well. Focus your attention on the problem, but give you a piece of code and then try to analyze that. In an exam, like in the quiz that you had, we are going to do problems. The problems will be like the problems that we have seen in your assignments so far, in the 4 assignments. And chapter 1 of the book I have put has a lot of other examples. Okay, so you should review them because one of the problems may be from there. The quiz that we had, there could be simple problems like that in the exam, in the midterm exam. Okay, what does this piece of code do? Or this piece of code has an error. How do I fix it? I won't ask you to write a code from scratch, but analyze the code, understand what would MATLAB produce if you type a certain command or a certain piece of code. Okay, so any questions so far? Now, next Thursday is your exam, and there was a suggestion that on Tuesday maybe we can have kind of a quiz. How many of you would like that quiz? Such a quiz. The purpose would be to kind of preview what is going to be on the exam, the structure of it. The problems may not be the same, but it gives you an idea of what to expect. Okay, so if you are game for it, it will be a condensed version of it because I'm not going to take more than 30 minutes for the quiz. Okay, but the exam you have the full 1.5 hours. So how many of you? Yeah. Oh, this is polling. Okay, I thought you had a comment. You had a comment. So how many of you would like to have something like that? How many of you strongly object? Nobody. Okay, so we will have it. Pardon me?
Or our options are quiz or review. Or
a review. A review would be that I go through some problems and review. You're taking the easy route out.
Can you put like a quiz on Moodle or something? Yeah.
I have, yeah, I'm glad. I was going to talk about all these things and I forget. I have posted some old exams, about 3 or 4 old exams on a zip file here. Okay, you can download that and you can look at and get an idea of the structure. As I said, these courses, these exams are given at another university at a different level, in the 3rd year chemical engineering level. So some of the problems may be a bit more advanced. We haven't covered, okay, in this course yet. So, but problems that you can understand, you should take an attempt at solving. And if you have questions, feel free to drop by and discuss them with me. Okay. So I understand the review is better than a quiz.
Yes.
Okay, I will do a review on Tuesday, next Tuesday. Okay. Any other questions or comments? All right. So far, we have finished basically what I wanted to cover from chapter 1 of the book, various types of models. After we saw the classification, we have developed one model of different type. We have not entered into partial differential equations. If there is time, towards the end, we will touch that part. So you should, in this course, I expect you to learn how to deal with ordinary differential equations at the most of our initial value problem and boundary value problem, and algebraic equations, nonlinear, unlinear. So the rest of the course, we are going to look at algorithms, developing the algorithms, answering the question, how does MATLAB do it? How does Aspen HYSYS do it? How does COMSOL do it? Okay, so these tools make our job easier in some sense. And so how do they do it? The reason for that is if things don't work, you should be able to diagnose. Why doesn't it work? What does it mean when I say the distillation column I'm trying to simulate doesn't converge? What are the possible reasons for lack of convergence? Things like that. So we'll set up examples and learn those concepts as we go along. In MATLAB, what I think you should need are these 3 topics that I have kind of highlighted. Okay, you should master that by the end of this course. Array structures. Okay, what do I mean by that? How do I create arrays? How do I manipulate arrays? How do I carry out operations with arrays? vectors with vectors, vectors with matrices. How do I build a more complicated array from simple instructions like the tridiagonal? We should be able to do pentadiagonal, things like that. And so if you have difficulty in that, you should spend some time trying to understand the basic idea of what is an array. Okay, MATLAB is meant for dealing with arrays in a very natural way. Okay, so you should understand this completely. How do you deal with arrays? How do you create arrays and things like that? The next one, for programming constructs, we have again exposed you to all these, the loops. The for loop, the if loop, and the while loop. Okay, and if you have difficulty, again, I can put some more examples to illustrate that. But by the end of this course, you should master what these loops are and how they are used so that you can start writing your own small programs. Okay, at this stage, all I'm saying is you should be able to write functions that define your problem, and then you use the built-in functions in MATLAB to solve that. Okay, and so that's the second concept, loops. And the third concept is functions. What do we mean by functions? What are the input arguments? What are the output arguments? And how do I pass information to a function? And how do I call one function from another function and pass information? Difference between local and global variables. That concept you must understand fully. Okay. If any of you have difficulty in any of these, come to me and I will try to explain it again, and I will give you some, through these help sessions, tutorials, I will try to build examples, not necessarily from chemical engineering, but from simple mathematical operations that drive home these points, like taking the series summation, writing an exponential function your own, sine function your own. Okay, so you might challenge yourself. You might say, okay, Kumar showed me how to do an exponential function. Let me try to do, how do I write my own sine function? Okay, so basically you're duplicating what I did, but going through the process and making sure that it works, you understand and you become more proficient and fluent in writing the MATLAB code. Okay, so these three are building blocks in writing any MATLAB program, and in any programming environment, you will find that these are important. Okay, so some may call it subroutines, some may call it functions, but the idea of modularizing something that you want to do and use it repeatedly, okay, like the cost function, for example, that you did in the last assignment, could be used with min search, could be used with just min to generate the data, to plot the data, and things like that. And you should continue to build on the number of useful functions. Okay, that you have to learn on your own. We will introduce you to some of the important functions. So far we have seen inverse, determinant, LU decomposition, eigenvalue calculation, fsolve, fmin search, things like that. Okay, MATLAB has more than 10,000 such functions. Okay, so nobody can know everything, but when you need to solve a problem, you need to know how to access which function does that and how do I use that. Okay, that would be the last skill that in terms of MATLAB that you would need. This, as I said, this list should continue to expand as you learn more about on your own. Okay, I just talked about the Cleve Moller, the link. So it's an excellent idea for you to download and use that as an additional learning material. Any questions, comments? Yeah.
How do you know all these functions? Like, since there's hundreds and thousands of them.
Right. You have to go to MATLAB help session and search by concept.
Okay.
That's the only way that you can do. Okay. You can start the help session. If you go to function browser, that gives a classification of functions. It will produce a big table. You can see. Okay. So under MATLAB desktop environment, data import, data export. Okay, so if you click on that, it expands and says, okay, how do I open a file? How do I load and save a file? So they have organized it by function. So if you click on that, these are the actual function names. And there is a brief description. And if you click on that, you'll get additional information on how that function works. Okay, and this is a huge tree. Okay, so you will see aerospace toolbox. Okay, and for us as a chemical engineer, the toolboxes that you will be using would be curve fitting toolbox, control system toolbox. Okay, the process control is an important part. Curve fitting for data fitting from experimental data, and Okay, if you become an investor ever, financial toolbox is there as well. But optimization toolbox is one thing that's important. Fmin search, fsolve, they're all in optimization toolbox. There is a PDE toolbox, and there are a number of other toolboxes. So this is how you kind of learn more on your own. Okay, I have an optimization problem. Let me see whether there is an optimization toolbox. I have a data acquisition need. I'm connecting my computer to a destination column. I want to gather the temperature and concentration profiles. Then you go into data acquisition. Okay, and that will tell you about how to do real-time data acquisition. See, there is a data acquisition toolbox. So from the context of what you want to do, you will be able to find that because this is well organized. This has developed over a 20-year period, and it's one of the well-developed and documented programs. But it's an important question. This is a question of answering, how do I learn on my own? Okay. After this course is over, if you want to use this MATLAB as an engineering solution environment, you need to learn how to learn on your own. Okay, any other questions? So now I'm jumping to chapter 3 in your textbook. Okay, this material is from chapter 3. Okay, chapter 2 is about linear algebra, and if there is a need, we'll go back and look at, but I think the concepts in chapter 3 are simpler to understand some of the algorithm development issues before we go into solving large system of linear equations. Okay, so we already know, if you give me an example of a nonlinear algebraic equation, how do I solve it? What does it mean to find the solution? For example, I have an equation f of x equal to 0. F of x is a function, it's a function of x, and I can plot f of x against x, and I can see how that function goes. And every place where that function is equal to 0, I call that as the solution. I call that as the root, R1, R2, R3, etc. Okay? So f of r equal to 0 is the solution. Okay? So I'm trying to find that value of x, those values of x that make the function go to 0. At other places, the function is not 0. If I put any value of x, I'm not going to be able to equate it to 0, so it is not a solution, only at those locations. Now, that function can have a set of parameters. We have seen this also. Okay? So in the case of the separation train, we do a degree of freedom analysis normally, and we count the number of equations and number of variables. The difference is your degree of freedom, and those are all lumped into this parameter set. These are inputs. So the solution can change as you change the parameter set. Okay? So for one set of parameter, I get this curve. For a different set, I might get a different curve. Okay, so the roots have moved, but this is for set P1, this is for a set P2, the parameters. So as I change the parameters in the equation, the curve changes and the roots change, the solution, the location change. Okay? If I am not clear in any of these concepts, please ask me. Okay? So this is what we want to do, is develop a general tool that will solve such problems, and then look at what are the tools that are available in MATLAB, and then develop our own algorithm, our own tool, and program it, and try to understand how the program works. Okay? So P is a parameter set, X is the unknown variable, and F is the constraint equation. We want to make F of X equal to 0. Simple example. Okay? F of X is sin X. I want sin X to be equal to 0. I ask you the question, what is X? How many solutions are there? Infinitely many solutions are there. Okay? Right, for every value of X where X is equal to n pi, okay, that is those are the root values. R equal to n pi, sine of n pi will be equal to 0. So if you graph that function, you already know that the sine function is going to be something like this. Just goes on forever, both forwards and backwards. Okay? So these are all the solutions where sine of pi equals 0. So that is a nonlinear equation. Sine of x equal to 0 is a nonlinear equation. Okay. So the one thing that we learned from such a simple example is that we cannot know beforehand, a priori, how many such solutions are there for any given nonlinear equation. So in this case, it's a simple one. We know the structure of the function, so we can say there are infinitely many solutions. But still, an unresolved problem in mathematics is for a given nonlinear algebraic equation, we don't know how many solutions are possible. How many places the function will cross the x-axis. You cannot predict it beforehand. That is not true for a linear problem. If I have a linear problem, ax equal to b, and if as long as a is well posed, it's not singular, its determinant is not 0, I will have only one solution. Okay, so a linear problem is basically a straight line. What graphical representation of a linear problem is, we have a straight line. Okay, the straight line will intersect the x-axis at only one position, right? So linear problems have that property. There will be a unique solution if the problem is well posed, meaning the determinant of A is not 0, A is invertible. We can invert that matrix. But for nonlinear problem, we cannot assert that at the beginning. So we don't know how many such solutions are there. Now, the unfortunate thing is most of the chemical processes or most of the processes in nature is nonlinear. Okay, nature, I always say that the nature hides its secrets in the form of nonlinearity. That's why you're not able to understand nature completely. We try to build models to capture its behavior through Newton's law of motion, through conservation of mass, energy, momentum, etc. But the model turns out to be nonlinear. In chemical engineering, these nonlinearities typically come from many sources, thermodynamic models, okay, or reaction models where you are converting ethylene into polyethylene. So if you're trying to model a polymerization reactor, you'll end up with a nonlinear problem. Okay, if you're modeling a distillation column, you end up with a nonlinear problem. Even simple things like pumping a liquid, crude oil from the well to the processing plant, a refinery, the flow rate, you will see in a fluid mechanics course, the relationship between the pressure drop and the flow rate is quadratic at least. Again, it's nonlinear. Okay, so we are forced to deal with nonlinear problems, and Aspen and HYSYS and packages like that make our task easy because we don't need to build the models. We just need to identify through icons. Here is a distillation column. Here is a pump. And it assembles the equations. It does the degree of freedom analysis. It sets up a solution framework for you using the ideas that we are going to talk about today. Okay? So the first lesson is, for a given nonlinear problem, we don't know a priori how many such solutions are there. In general, the nonlinearity is a general one. But there are some specific types of nonlinearities. There are a few examples here. The first one is f of x equals x cubed plus 4x squared plus x minus 6 equal to 0. How many such solutions are possible where x will satisfy that equation? That's a polynomial. Okay? So when you have only a polynomial degree of type of nonlinearity, we can say that the highest degree of the polynomial is third. So when you graph this, you will have, for this one, only 3 such possible solutions. It may be like this. Okay, a cubic equation can have only that structure. A quadratic is a parabola. It can have only 2 such solutions. Okay, so the highest degree of the polynomial, only for this one, there is a well-established theory which says how many solutions are possible, and you can predict beforehand, as long as it's a polynomial of a certain degree. But sin x, is it a polynomial? If you write it as an expansion, sin x is an infinite series. Even e to the power x is an infinite series. Okay, so these are all names that we give to special forms of infinite series: e to the power x, sin x, cos x, tan x, etc. Okay, so and when you have a combinations of nonlinearity, it's really impossible to predict how many such solutions there will be. So here I have 3 cases, 3 different polynomials. In the first case, I said that I have 3 distinct roots. So in this concept also you need to understand, what do I mean by distinct root? What do I mean by repeated root? Okay, so these roots are -3, -2, and -1. I have a graph somewhere later on. Here. Okay, so this is the 3 roots, -3, -2, and -1. So the x-axis is here, y-axis is here. Okay, so that is -3, that is -2, and this is +1. That is the equation for this function. Okay, so at r equal to minus 3, minus 2, minus 1, the function is equal to 0. Okay, but if you take the second example that I have, what I have done is I have changed the coefficient. And here it is x cubed plus 4x squared plus x minus 6. Okay, so these coefficients are like the parameters. So if you change that parameter to a different number, the curve will move up or down. Okay, so I have picked the numbers in such that I have x cubed plus 3x squared minus 4 equal to 0. And what do you see as the difference between these two graphs? Maybe I should try to shrink it a bit. So that you can see both. Can you see at the back both the curves? Okay. What is the difference between this curve that you see here and this curve? These are two different polynomials, two different parameters. Both are third degree. How many roots do you have for this case? 2, right? So it is as if I'm taking this curve and changing the numbers in the coefficients so that I'm lowering that curve gradually. And I picked the numbers such that these two roots have become closer and closer to each other and merged at this point. Okay? So you say that there are only 2 roots, but in principle, a cubic polynomial should have 3 roots. But what happens is here the 2 roots occur repeatedly. Okay, so at minus 2, for example, the root are minus 2 and minus 2 and 1. What does that mean? If you do this factorization of this polynomial, you will get something like x plus 2 squared times x minus 1 equal to 0. Okay, that x1 and x plus 2 squared is the one that says that 2 occurs with a multiplicity of 2. That the root at minus 2 occurs with a multiplicity of 2. And one of the features that we should notice is when that happens, what happens to the first derivative at that point? It's 0. Okay? Normally, if you take the first derivative at these points, the first derivative is not 0. So we call that as simple roots. Simple solutions where the first derivative is not 0. And we will see some of the algorithms that we are going to develop will fail sometimes. Even fsolve will fail to converge. We are now trying to equip ourselves to understand why. What are the possible causes? So if I have a situation like this where 2 roots are merging, I will experience difficulty with certain algorithms. Okay? Because not only the function is 0, but its derivative is also 0, and so the function occurs with a multiplicity of 2. Now I change the parameters a little bit more. What has happened is this curve has gone below. Okay, so the maximum which was here is going down in this direction. So there is no maximum on the figure that I have on the right hand side. How many such roots do I have now? 1, right? But I know it's a cubic equation. So the theory tells me a cubic equation should have 3 roots. What happened to the other 2 roots? This is a think, pair, share exercise. Well, recall. You need to recall what you have seen. This you have seen, I think, from probably high school algebra. Okay, so I have a third degree polynomial, and I have 1 root to that, and it is a simple root. It doesn't occur with a repetition. Very important to understand. Okay, on the figure on the left hand side, there are 2 roots. 1 occurs with a repetition twice. How do I know that? Because the first derivative is 0. When it occurs with a repetition of 3, not only the first derivative will be 0, but the second derivative will also be 0 at that point. So you will have an inflection point. That's also possible. You can construct these very easily because you can just make up a polynomial which says x minus 4 cubed equal to 0. You expand that, you're getting a third degree polynomial. That will have x equal to 4 as a root, but it will occur with triple repetition. So at that point, you will find that the first derivative and the second derivative will be 0. Okay? So, to see whether you can recall, what is happening in this case? What happened to the other 2 roots? Pardon me? There is no inflection point here. If there is an inflection point, then you will have 3 three roots that are repeating. Okay, an inflection point like the tangent here is actually like this. An inflection point would be something like this. Okay, the derivative is 0 and the second derivative is 0. You can verify that. You can take that expression that I have here, take its first derivative and second derivative, and put r equal to 1 and see whether it is equal to 0. Okay? So do you remember anything from...
Imaginary root.
Excellent. So the other two roots are imaginary roots. Okay? So if you're using any of the fsolve, they may not be able to find those imaginary roots because it does all the calculations in real space. But MATLAB naturally switches to imaginary space and it can find the complex roots as well. And the theory again tells you that when you have all the coefficients of the polynomial as real numbers, then the imaginary roots or the complex roots must occur as a pair of complex conjugates. So there must be two roots that are complex conjugate of each other and that are complex. There is a real part and the imaginary part. Okay? Any questions so far? So what we have done so far is talked about some of the properties of nonlinear algebraic equations. So you should know that if I give you any arbitrary nonlinear equation, there is no way you can tell how many solutions will there be. And so you need to provide fsolve with an initial guess. So the challenge of what is a good initial guess is a problem. So you need to use your understanding of the physics of the problem. If you're dealing with distillation column, if you're dealing with temperature, you know while you're separating water and methanol, you're distilling methanol. So methanol temperature is maybe at 70 degrees, water is 100 degrees. So somewhere in 90, maybe a good guess. You won't give 2000. Okay? So the physics drives some sort of a good initial guess for solving such problems. Okay? And for certain problems like repeated periodic functions, you know the structure so you can tell where the roots are located. But in general, you need to solve for these roots by a trial and error procedure. And for polynomials, the number of roots is determined by theory. That is equal to the highest degree of the polynomial. And if the roots are not real, then they must occur as complex conjugate pairs, some of them. Now, we are going to see how fsolve is developed. Okay, we're going to see some algorithms. What is the general procedure for developing numerical methods for solving nonlinear equations, whether it is algebraic or differential? We're going to see the algorithms. So the general procedure is the following. Okay, I have a nonlinear equation. I know how to write that function. I can write f of x equal to something. So in MATLAB, if I throw an x, it returns an f. Okay. Then what I need to do is make a guess. Make a guess for x. Okay, and send that to the MATLAB function, and it returns the function value, which is not 0. So now I am doing the task of what fsolve does. Okay, I'm going to write, I'm going to develop the concept, I'm going to implement it as a code, and I'm going to test it. Okay, so my task as an algorithm that fsolve will do is to probe, to send values of x to this function, get back values of f, and if they are not 0, the next step would be I should be clever enough to build a better guess. I ask from you only for one guess, sometimes two guesses. Okay, using these guesses, I must be able to build a next guess that is better. And then if I repeatedly use that algorithm, that idea, I can always find a better guess. Give me whatever guess you have, I can build a better guess. Okay, and repeat that process, then I should be able to converge. The idea of convergence is to go to the target, that is the root. I need to find the root where the function is equal to 0. Okay, so when that process is applied repeatedly, then I get convergence. Sometimes I don't. I get divergence. I go away, far away from the desired root. Okay, so that depends on the scheme that I'm going to develop. So first, make an initial guess, and next, make a scheme, devise a scheme that improves on the initial guess. Can you guys see at the back? I need to maybe blow this out. Okay, so we're talking about developing an algorithm. The first is make a guess for the solution, and the second step is improve that guess. Devise a scheme that when applied repeatedly will improve that guess. The last step is you need to know, I cannot be doing this indefinitely, so I need to know whether I have converged, whether I have reached the solution. Okay, so that means I need to check whether the improved guess satisfies the solution criterion. So I need to come up with the criterion. Okay, and if the criterion is not met, then I need to go back and repeat that step. So there is going to be a loop here. Okay, what am I doing? Between second and third, there's going to be a loop. The second step is going to be applied repeatedly. Third step is going to check whether I need to do it one more time. And then once it's finished, I come out of it and I come out with a value for the root. That's a basic algorithm. This is what we would call an algorithm. Conceptually, we are figuring out what we need to do, the steps, and then we are going to develop the specific mathematical implementation of this concept. Okay, any questions? The first one is called the bisection algorithm. Okay, what is the concept in the bisection algorithm? The very first step says you need to give me two guesses. Okay, so not one guess but two guesses, x1 and x2. Give me two guesses, and such that it requires, this bisection algorithm is the simplest one to understand, okay, and simplest one to implement, and then we'll improve on it to algorithms that reach the solution quicker, faster. That says that the two initial guesses that you provide must be such that I know for sure that there is a root in between. What does that mean? It means if I evaluate x1, I put x1 in here, and your function gives me the function value f1. And then I send in the next value x2, and your function returns f2. If I take the product of f1 and f2, and if it is negative, what does it mean? Okay, if that's not clear, just draw a sketch. There is one is positive, one is negative. So the product is negative. F1 is positive, F2 is negative, or F2 is positive, F1 is negative. So if I'm plotting that function f of x against x, okay, and I pick this as x1, and I pick this as x2, so that's going to be f2, and this is going to be f1. So f1 and f2 are on either side of the x-axis. One is positive, other is negative. When I take the product is going to be negative. That immediately tells me, there is at least one root between those two guesses. Okay? But if you give me arbitrarily two numbers, x1 and x2, and I do this calculation, calculate f1 and f2 and take the product, they have the same sign. What does it mean? Can you say for sure that there is no root? You cannot say that. That's a failure in this method, for example. Okay, so you could have a situation where the function does this, and unfortunately you didn't know about it, so you picked x1 here, and you picked x2 there. Both are negative. So the product is going to be positive. There is no sign change, so you say, oh, so I don't have a solution. That is a drawback in this method. Okay, FSOL doesn't have that drawback. Okay, so you might get into a situation that you should be aware of. Okay, do you understand that? So this is a good check that the product, if the product is negative, you are guaranteed that there is one place where the function switches sign, where the function is likely to be 0. Can you find an exception to that rule? Can I always say that if the product of f1, f2 is equal to 0, that there is a root in between? Pardon me?
Do you say equal or less?
Less than.
Yeah, what if it's diverging, where it goes from infinity, to infinity, negative, to infinity, positive.
Right. So there are many, like if there is a discontinuity, okay, it could be bounded but discontinuous, or it could be going to infinity somewhere in between. You could have functions. If you plot, for example, tan h, you will find a behavior like this. Okay, so maybe it's like this. Okay, it goes to infinity every periodic step, and like this. We will see one function like that later on. that comes from distillation column. Okay, so it's a rule that we are developing. Okay, and numerical mathematics basically develops in an ad hoc fashion like this. Okay, so we have two guesses, and it is likely that if it is less than 0, that there is a root in between. But there are exceptions we should be aware of. Okay, now we take this to be true, that when the sign is changing, that there is a root in between, and we want to find out where that root is. Now our task is to go to the next step, the second step, and say, what is a better guess? What would be a better guess? Midpoint. This is why it's called the bisection method. You are bisecting at every step. Okay, so X3, the simple algorithm, simple algebraic expression is the new value that you are going to propose is just halfway between the two values that you have agreed upon. Okay, you know that there is a root in between x1 and x2, so x3 is going to be halfway between. So x1 plus x2 divided by 2. Okay, so here is a graph of that. So I initially put in x1, and my function returns f1, the function that I write for any problem. And then I put a second guess x2 and returns f2. And I take the product of f1 and f2, it is negative, so I know that there is a root in between, assuming the function is continuous between those two. There are no discontinuities. Then I say, okay, my x3 is exactly halfway between x1 and x2. So it's a very simple formula. x3 equals x1 plus x2 divided by 2. That's all I do. Okay. Now I can send that to the function, and I will get my f3 back. What would you do next? Exactly. I hope everybody gets that. Okay. If you get that, you can see that it's not really magic. It's very simple. So your logic to implement that is going to be a bit tricky. Okay. This is where you need to understand how the if function works in MATLAB to be able to implement that. But conceptually, what we need to do is, as I said, the second step should be something that is repeatable. Okay, so that I successively go towards that. So at this stage, I have to devise a program that will discard x2, because x2 is on the wrong side. Okay, so if I take the product of f1 and f3, I will get a negative value. So I know that I must keep x3, discard x2. So essentially what I should do is, I should rename this as x2, rename this as f2. Forget about this one. Forget about this one, rename x3 to x2, f3 to f2, and then I can send it back. I put a loop around that. So the next value for x3 will be the average of x1 and this number, which is the new improved value. And so you will automatically put a loop, and that will work infinitely many times. Right? So what you need to do is then say, okay, when should I stop? How close should I be to R before I can stop? That is the third criterion. So how would I check for that? Yeah, you will take the midpoint and continue to find, okay, the midpoint of this may be here. Okay, then you will discard x1. That is, label x1 as label new x3 as x1. Okay, but that process we will see. Once you see the code, you will understand it. But if I say go and write the code, you will be in trouble. I know that. Okay, so that is why I have lots of pieces of code in the notes that you should go and study for bisection method, for secant method, etc.
How would you know, like, I guess, what side to just take off? Is it because, like, a bisector has to be on each side of the x-axis?
That is the basis of the bisection method. Says you give me two guesses, and I will continually improve those two guesses.
They have to be on opposite.
They have to be on opposite side, right? If you do that, if you violate that, you're not going to get to the root.
So say if you did F3 and F1, and the middle one was, say, negative, then you would take off F1 and use that.
Exactly. So conceptually, that is what I want you to understand at this stage. What is the mechanism? The mechanism is you calculate x3 as the average of x1 and x2. Then calculate f3. Okay? And then decide whether f1 times f3 is negative or f2 times f3 is negative. Those are the two possibilities. Okay? So if f1 times f3 is negative, you know the root is between 1 and 3. If f2 times f3 is negative, you know the root is between those. So depending on those checks, you will say, okay, I want to keep either x1 or x2. Okay, so your choice at this stage are, you're going to, after calculating F3, you will check. You will check whether the product of F1, F3 is negative or F2, F3 is negative. And if F1, F3 is negative, then you need to keep X1 and relabel X3 as X2 so that you can put a loop around it. Okay? The product of F2 and F3 is negative. If it turns out to be negative, not in this picture, then you will label X3 as what? X1. Right? That is the logic. So once you understand all this, you will be able to put the. Okay, let me repeat that slowly, and if not, maybe you have to ask me, and I'll try to draw another sketch. Okay, so I'm trying to explain with this sketch. In this sketch, the root happens to be at this position between x1 and x3. So my logic is, I calculate x3 first as an average of x1, x2. I calculate f3. Then I take the product of f1 and f3. If that is negative, then I take x3 and relabel it as x2. Because x2 is no longer relevant. The old value of x2 is no longer relevant, but the x2 is just a placeholder. I can put a new number into that. Okay, so I'm going to replace x2 with the new value, which is x3. But if f2 and f3 turns out to be negative, this sketch I don't have. If you want me to, I can draw the sketch. Okay, suppose the root turns out to be something like this. Okay, so this is your f2, and the root is here, and this is your f3. So if f2 and f3 turn out to be negative, the product of f2 and f3 turn out to be negative, then you want to keep 2 as it is, but you don't need 1 anymore, right? So you take 3 and put it into the location of 1. Okay, so you're just going to have 2 locations, x1 labeled x1 and x2. They're going to keep storing numbers in there, and these numbers should approach each other. That is, the difference between x1 and x2 should go to 0, and that is what we call convergence. That is, they should approach each other. Okay, if the difference between x1 and x2 is less than 10 to the minus 7, we say, okay, the x3 is going to be somewhere between the average of these two numbers, then those numbers are already close to each other. So you say that you have converged. The other way would be to say, check whether the new f3 that you have calculated, what would that f3 be as you are approaching this point? As you are converging, that is, as you are repeating this process, f3 should move towards that point from either side. Okay? So f3 will be a very small number, 10 to the minus 7, 10 to the minus 8, 10 to the minus 9. So you decide. If it is less than 10 to the minus 4, I'm happy with it. Okay? So that is called the convergence criteria. So you have to check. That will be the last step. Every time you calculate f3, you not only check whether the product of f3 with f1 is negative, you also check what is the absolute magnitude of f3. And if it is less than 10 to the minus 7, you say, okay, that's enough. I can quit and return that value of x3 as the root. Okay, so conceptually we have laid out how this algorithm is going to work. Okay, start with 2 guesses, calculate the 2 functions, check whether the derivative, the sign change is there between them. And if it is, then calculate a new value x3 and repeat the process by switching x3 into either x1 or x2 conditionally. Any questions on that? Is that any better? You understand now? Okay? Okay? Good. So the third check is the convergence stop. So we just simply say that if the absolute value of f3 function that you calculate is less than epsilon, epsilon is a small number. We call it tolerance. Okay? So it could be 10 to the minus 4, minus 5. You decide that, how accurate you want the results to be. 4 significant digits or 9 significant digits. You cannot do it for 20 significant digits because MATLAB is limited to about 16 significant digits. Okay, double precision.
So we keep that doing until we get the solution.
You keep repeating this until you get the solution. Or, in some cases, this is a good point, in some cases, you may never meet this criterion. The function never reduces to 10 to the minus 12. Okay? never meaning in a finite number of times. So you need to put a condition. Attempt only 100 times. If in 100 steps you're not able to get there, put an error message and get out of this. You don't want an infinite loop because MATLAB will then be doing this calculation forever. Okay? So in any good program, you'll always have a catch for that situation, that exceptional situation. Where it does, when it applies this, you don't want it to go into a loop forever. So these are the elements that we need to put together in a program. And this is a program taken from your text. And I'm going to ask you to guess what every step does. Okay? So the very first step, what does it do? What is R in there? R is the root that we are going to return from that function. So when I call this function bisect, it should do its magic, get the converged result, and send it out as in the variable R. So somewhere in this program, I must have R equals the best guess for the root that I have found in this algorithm. Okay? So I must have a statement somewhere. A very important point, because some of you still make that mistake. You call it as something on the left-hand side of an equal sign, but it is never calculated in your function. Here, you will see that it is this, R equals x3. Okay? So in fact, this is where I say, if absolute value of f3 is less than tolerance, R is equal to x3, and then return, get out of this function. Okay? So return is a command that exits from this function. So that is the line where I'm actually testing whether things have converged or not. But before we come there, let's go back. And can you guess what this might be? The first argument. Name of the function that we are going to pass to bisect. Okay? So we need to write a function that we want to drive to 0, which you have done many times. So that name comes in. Fsolve handles it the same way. Okay? And you can put these arguments in any order you want, but you should know which order when you're calling it. So I'm following the same system that MATLAB uses. The first one is always the name of the problem that you want to solve, the name of the function that you write. What would be the second one? Guess. In this case, what should be the length of vector x? 2, because this method requires 2 guesses. Okay? So I must check whether the user has passed 2 guesses. If not, print out an error message and quit. Okay? I must do that. The third one is something called TOL, T-O-L, tolerance. That's accuracy, how accurate you want the result. So the user can specify 10 to the minus 4, 10 to the minus 7, whatever they want. But if they don't specify, we want the function to be automatically default to something. Okay? And this is how, again, all MATLAB functions are constructed. So with this, I'm telling you how MATLAB goes about constructing fsolve, fmin search, and things like that. You will have a set of input parameters. Not all of them are essential. Some of them are essential, some of them are optional. How does MATLAB handle those optional ones? We are going to see in this function. Okay? The last one says trace. That is again an optional flag which says, as you are doing the iteration, print out intermediate results so that I can watch how the iteration proceeds. How does it x3 calculated from x1 and x2? Okay? And we will activate all these and see. But we will call third and fourth argument as optional arguments. The first and second are necessary arguments. You must provide them if this function has to work. Okay? And then I have a series of comments. And those comments are the help, built-in help. So if I go to MATLAB and say help bisect, it will come to this function bisect and look at all these lines and print them out. That is how MATLAB provides help. Okay? Up to the line that has a blank line. Anything after that, it is not printed. Okay? So this section is basically help, and this is just some additional information, comments, that we are documenting what each line is going to do. So the usage is you call the function name, and then you give 2 guesses. I'm telling this is how you should use that. And 0 and 1 are the initial guesses. Now I give you this piece of code, and you come to the next line. Can anybody guess what that line does?
He didn't provide 4 arguments, 0.
Very good. If you did not provide 4 arguments in the input, it says the 4th argument is neglected, so I'm going to set it to something. Okay. So here I'm using the construct. What is the construct for if? It is always if. What's happening? If certain logical condition. It's very slow today. If certain logical condition is true, then execute the next piece of code. If it is false, don't execute that piece of code. And it must always be ended with an end. The if loop must have an end. Okay. So all this are put in one line. But you must ask, what is NARGIN? MATLAB has a number of built-in variables. Pi is one, for example. If you type pi, it knows what is its value. That's called the built-in variable. Okay. Similarly, there's something called EPS. It stands for epsilon, a small number. So that is the machine precision. Okay, 10 to the minus 16. Okay. Similarly, if you type NARGIN, of course, this is how I would go learning. I saw a new piece of thing. I didn't know what it is, so I'm just typing what it is. It says it's 0. It's also a built-in function. Okay. So built-in function, they should be able to provide some help. This I've never tried, so let me try. Does it provide a help for NARGIN? So it does. Okay. So it says number of function input arguments. What does that mean? This is what you should be able to do eventually. That when you read, you should decipher. You should understand what they're trying to tell you. Okay? NARGIN, I'm guessing, is a variable which is going to have a number, and that number is going to be equal to the number of arguments that I pass. So it can, in this problem, it can be 4, it can be 3, it can be 2, it can be 1. Because the function requires 4 inputs, but I may not provide all 4 inputs. So if I pass, for example, if I call this function saying bisect function name and x, and then close the parenthesis, okay, then I'm passing only 2 arguments. So NARGIN will have 2. Value of 2. Are you following me? Some of you turn off when it comes to MATLAB code and thing, right? No, you need to make an effort, okay? So NARGIN is going, it's a variable, it's a built-in variable. It's going to have a number. That number will represent the number of input arguments that I put in. That it simply knows where they come out. If it sees a comma, say, okay, 1 argument. If you see another comma, that means I have 2 arguments. And then put a parenthesis, says I have only 2 arguments, this is going to be 2. If 2 is less than 4 is true, then I'm saying, okay, the user did not bother to give the variable trace, which is in the input sequence. So he does not care to get tracing information. So I set it equal to 0 and end the loop. Okay? This is a safeguard, default. This is how MATLAB handles setting default values. If you don't choose one, it will check and it will set a default value for you. Any questions on that? Okay, then explain to me what is happening in the next line. If you pass only 2, okay, then I say you have to set both the tolerance and the trace. So tau is equal to EPS. What is EPS? The epsilon, the machine precision. And trace equals 0 and n. Can I have them altered? Can I put if NARGIN equals 3 first and then NARGIN less than 4? That's what you need to think about. Okay? So I'm not going to provide an answer to that. Think what would happen if I switch these around. How important is it to have in this particular order? Okay? Then what am I checking? The next thing I need to check is how many elements are there in X. So if the length of X is not equal to, this simply means not equal to 2. If the length of X is not equal to 2, meaning it is 3, it is 1, then I'm quitting. I'm saying error is the name of the function. And what does that function do? Simply prints out whatever the error message and quits the function. It exits from the function with a beep. Okay? Any questions? Yeah.
What sort of value would you use to trace? what sort of value would you enter for trace?
You have to see how trace is used later on. Okay, if trace I'm using as a logical variable, so it has to be either 1 or 0. Okay, if it is 1, then it will print out additional information. If it is 0, it won't.
So you get into yes, no, and
Yeah, exactly. You see here, that's the only place where I'm using trace. If trace, meaning if it is true, if it is 1, any other value is treated as false. Okay? If it is true, then f print f. So it's going to print some additional information. What does it print? It prints a current iteration number, current value of x3 and f3. So you can see how it successfully calculates x3 and f3.
so even if you enter like 5, it'll accept it as 0 and say no.
I believe so. I cannot confirm that. I believe that 1 is true, everything else is false. That's what I think. Okay, so the algorithm is really not very difficult. The algorithm itself, the code of the algorithm is in these 3 lines. All we are doing other than that is setting up, validating the input. Okay. So in the next line, what do you think I'm doing here? So I have 2 acceptable inputs, and I have initialized all the default values. I come to this line, and I say f equals feval fun x. What am I doing? So this is the first time you are encountering that. What will you do? You will need to understand what is feval. Okay? It evaluates, you can guess. That's very bold. You can guess that it evaluates a function. So at this stage, it passes control to the function that you are going to give it, which is the name of which is in this variable. So fun is a string which has a name of the function that you are going to call. Okay? So feval simply transfers the control together with the x value. And it expects to get 2 numbers, and those will be stored in f. So f will be a vector of length 2. Those will contain f1 and f2. Okay, we pass x1 and x2 through feval and get 2 values f1 and f2. Okay, what am I doing in the next line? Prod. What is prod? What do you think prod will do? Product, right? So if you have an array of 2 numbers, it just takes the product. Of course, if you have an array of 10 numbers, prod just takes the product of all of them also. But in this case, all I want is the product of 2 numbers. Then this is actually coming from another function, sign, sign. What do you think that will do? Just extracts the sign. Okay? So if I have, this is why I said, you can test individual pieces, try to understand it. So go to MATLAB and create a function f that is equal to -1, 3. Okay? Suppose feval return those 2 functions. If I pass them to sign, what does it do? Return. Oops. Sync. My typo created an error message there. Sign of f. Remember, f has these 2 numbers. Sign of f extracts only the sign. So it gives you -1 + 1. And then I take the product. Okay. So if I say PROD SIGN f, this is the piece of code I have. So I want to understand how it works. So I type that, and it says -1. So the sign extracted the 2 signs, plus and minus. I take the product. It says it's negative. So I know that I have a root in between if that happens. Okay?
You just took 1 for the second one, right?
Pardon me?
You're giving a value of 3, but it took 1.
No, the sign would return. It will drop the magnitude.
Oh, okay.
It will return only the sign. So +1 or -1. Okay. So here I'm saying if the product of the sign of f is greater than 0, that means there is no root. We know already that is not true, but we have programmed it in such a way that if there is no sign change, we assume that there is no root. Then again, it calls an error routine and says print out this message: no sign change, no roots. Okay, and then end. So by all these, it will exit. At this stage, it may exit the function. At this stage, it may exit the function. Yeah.
Are you going to sign f to make it more precise? Like, because you can't multiply really small numbers times each other, and the why you didn't sign f, I guess.
I'm not following.
Instead of just doing the product of the two functions.
It's saying if for
Well, I know what it says.
Okay. The question is, what would happen? Let me understand. Is that the question? If I don't have the sign,
Yeah, I mean,
right?
if you multiply each other.
If you multiply just the product F1 and F2, that will also give you a sign change, right? But as you pointed out, sometimes F may be a very small number, right? And you're saying that it is greater than 0. It should still work. Most of the times it will still work. But round-off errors can create problems when the numbers F1 and F2 become small. And the sign will reset the magnitude to 1. Okay? But that's a very good question. So you should try it. What happens? Does it work if I take the sign out? And most situations it will work. Okay? Then I set up the real algorithm. I say for I equals 1 to 100, I already figured out x3 is the average of x1 and x2. Notice the way I have subscripted. Because x comes as a vector, so I put subscript for x1 plus x2 divided by 2. But I did not create x3 as an array. I created x3 as simply a variable. Why? Because it's only a temporary variable. Because I'm going to use only these two locations, x1 and x2, for repeated use. x3 is a temporary one, and I'm going to check whether so the next line, for example, I pass x3 and I calculate f3. I make the same call to the same function. F3 use the x3, return me f3. So here I'm passing control to the function, getting back the new function f3 value. Then I say which one should I keep? The next question is, should I keep x1 or should I keep x2? I know I'm going to keep x3. Okay, so that is a new value. So out of the two, x1 and x2, I should discard that. Which one should I discard? So here I'm doing sign of f1 times f3. If that is negative, I know the root is between f1 and f3. So 2 is no longer needed. So I take x3 and put it into x2. I take else. If that is not true, this is a quick way of capturing both situations. If f1 times f3 is negative, then I'm repeating it here. Okay? If f1 times f3 is negative, then I know that I don't need x2. I need to keep only 1 and 3. So I take 3 and put it into x2. If that is not true, then the other must be true, which means I need to take x3 and put it into x1. Okay? So it's really a compact way of handling both cases. If f1, f3 is negative, that's true, then I take x3 and put it into x2. That is not true, I know the other one is true, so I take x3 and put it into x1. So what I've done is I have flipped over, I have discarded the one I didn't need, and I saved x3 in the proper location, either x1 or x2, conditionally. Okay? And then I check if the absolute value of f3 is less than tolerance, it's converged. I'm happy with the result. I take x3 and put it into R. This is very important because this is the value that gets returned. I have R equals the function, right? And then return also takes me out. Okay? And in addition, I say if trace is true, that is if trace is 1, then print out. Print what? Print the iteration number, how many times I have done the calculation. Print out the current value of x3 and the current value of f3, every iteration, so that I can monitor progress, iteration proceeds. What does the last line do? When do you reach the last line? If I goes over 100. If I have completed this loop 100 times, and I still haven't satisfied this criteria, it's not converged. Okay? Then I kick out of the loop, and I say exceeded maximum number of iterations. And why you would have that, for example, you are monitoring the iteration, it goes to 10 to the minus 5, but you need 10 to the minus 7. So what would you change to make it work? Do you follow my question? You are printing out your monitor, yeah?
Just raise the number of iterations.
Raise the number of iterations. Okay, go back and change 100 to 200. If you know that you are converging, to 10 to the minus 5, you need to go to the minus 7. If it goes to blows up, then you need to do something else. Yeah.
What's with the 12.5? What is that song? Is that just
This one? Oh, yeah. This this is the first time I'm using this. You don't have to use that, but what it says is it's a more detailed format specifier. Okay? That basically means use 12 positions and 5 positions after the decimal point. So you're using F is for floating point. Okay? So this says print the number in a decimal form, not in an exponential form, and use total of 12 places, but reserve 5 for after the decimal, the remaining for before. Okay? So if I have 12 positions and I have 5 positions after decimal, I need to have 1 position for the decimal itself, and I have to have 1 position for the sign. 7. I've taken 7. So the remaining 5 would be used for before. So I'll have 5 digits before and 5 digits after the decimal. We can change this number to anything we want. Okay? 12.3, 12.2, whatever. So that simply says, like 3i, for example, says use 3 positions for printing the integer. Because I'm going to print only up to 100 maximum. Right? So I'm using that. Any questions? Yeah. Good question. Can I use a while loop? The answer is absolutely yes. Okay, you can use while loop. That way you don't have to worry about how many iterations. But you need to have an escape from the while loop, because the while loop could potentially be an infinite loop. While this condition is satisfied, for example. Okay, if this condition is not satisfied, you want to keep repeating it. If the condition may never be satisfied. Okay, so that's why it's better to put a maximum limit. So I have tried to show you how to understand a program that somebody else has written. Once you get that comfortable, then you can write your own programs. In the next class, we will run it, we will probe, setting up breakpoints, how this works.